session. This session is the title is moving forward through darkness. It's different to your menu because I changed this topic and content. Because I came from Taiwan, but so I changed a little late. So you receive the different topic in your menu, but I will deliver this speech. Moving forward through the darkness. Yeah. We do a lot of data mining every day. When we are doing data mining, just like it's to solve the real business problem, it's just like moving forward the darkness. Most of the time, we didn't know which is the right direction, which is the answer to the business problem. The most of the time, we only have the potential direction, and we can try and follow. So that we cannot see the true answer. So most of the time, just like this, you cannot see the future. You can only see the thing in front of you. So you cannot know what is the result in front of you in the future. We always working with the uncertainty in our daily life. We always moving forward through the darkness to the brightness. So today I will sharing you that how I break through the brightness of the modeling of the machine learning and data mining model when you want to use the model to solve your business problem. Hi, I'm George. I came from Taiwan, and I have a lot of experience in quantitative trading and e-commerce consulting, and also help a lot of clients to build their recommendation system and search engine. And the most important thing is I love Python, and I want to share Python to everyone to help their daily life. So this is why I here. Okay, back to the topic. I want to show you training model from data is just like sketching picture from the world. It's just like imagine when you are sketching an apple, you from the macrostructure to the microstructure. So you draw the shape and draw the shadow and the luminous. It's just like when you are doing your modeling job. The most famous painter, Jackson Pollock, said, "The paint has its life of its own. I just try to let it come through." I think as a data scientist, we have the same words. The data has its own life, and we just try to let it come through. So how to let your data come through? It's just like sketching. We can see there are a lot of people in this. They are trying to sketching the tree in the center, and they stand on the different angles. The first step of sketching is not picking up your pen. It's choosing an angle and do some observation. It's just like we always do the exploratory data analysis when we try a new data. We not do a heavy analysis. So just like this. Now, the object changing from the tree to your data. It's just like this. It's your object. You need to draw some picture of your object. So how can we draw? We can draw a lot of lines, straight lines, and it has the slope and also intercept. So we can plot every line as a point on your right-hand side. So remember that there are a lot of lines and points, and which is the most similar one, which is the most similar painter paint to the tree. We need to choose an angle, and what the angle means in linear regression is its objective function. So the objective function defines which paint is most similar to the object, and it defines which lines is most optimizer to your objective function. So you can also draw your objective function because it's a simple linear regression just with single dimension input. So put things together. You can see that in your left-hand side, there is a data here and also a lot of lines, just like your pen to the tree. And there is a lot of picture here, just like the lines over the data. So when we want to define which is the most similar things, we need to choose an angle. So like the boy, he chose this angle, maybe he will think that her parent is not similar to the tree, but her parent is just to represent another boys in the world. So the same thing in the data mining and data analysis. After you choose an angle, you can solve the optimizer from gradient descent. No matter what you use linear regression or no matter what you use deep learning, it's the same. You can use stochastic gradient descent to easily to solve your model after you write down the objective function. So how to change our angle from the linear regression problem? You can add the weighted to your data, because just like I try to construct a lot of trading strategy in the option market and future market. Some of data are most important to the others, because some of data makes you earn a lot of money or lose a lot of money. It's much important to the data that make you earn small money and that you lose small money. So some is important. So you should not to train your model with the equal weights. Yeah, you should train your model with different weights. After you add different weights to your data, the objective function change, and your angle change. So you can observe different vision, different picture. So when you are adding 100 times and 10 times to these 2 points, the different level curve are just your right-hand side. So you can solve different pictures. You can draw different pictures, just like this. So it's a metaphor that the data is your object. The evaluator is your objective function. It represents what the vision, what the angle you observe the world. It's the most important thing. We always use a lot of package like scikit-learn, like Keras, or a lot of things. Yes, they can help you to solve things quickly, but they cannot let you to solve the model you defined. Yeah, so how to solve the true problem, which much more approximate to the real world. It's much important. It's really, really important. So how to make your picture just look like the real world. So the model is the outcome. So you can the whole things you can control is the data and the evaluator. So it's very, very important. Just like the metaphor. The data is here, and the evaluator is your angle, and the outcome is the pictures. Okay, I do these things every day in a lot of business problem area, in e-commerce, in trading, or in the news platform. And I will give you a couple of examples in those kind of area today. So different angles create different pictures. That's in sketching. And different questions create different model. It's in data science. And what you observe, what you draw, it's in both. Yeah. It's the most important concept I want to deliver today. And there are 2 keys that can help you to apply your machine learning method in the real world more accurately. accurate. So the toolkit is asking questions and finding solutions. You can see the right-hand side is the question part, and the left-hand side is the solution part. They can also separate into the real words and also the imagined words. Imagined word means the machine learning words, and also the mathematical words is the imagined words. We learn a lot of solving model skill from the school or online courses, so that we can solve a lot of different kind of machine learning problem or different kind of mathematical problem. That's if we can change the real world question into sort of machine learning questions or sort of mathematical questions, then we can solve it by the skill we learned from school. But school didn't tell you. School only tell you when and where the algorithm works well, but school didn't tell you when and where it didn't work anymore. Yeah, but I think that the situation it didn't work anymore is more important to it work. So that's why I'm here today to share this kind of topic. Yeah, and after you decompose the problem, you can solve by the skill you learned in the school. And after that, you need to compose your solution together and back to the real world to check is the real solution to the real question, or you solve another problem. Most of the time, we solve another problem, not directly to the original problem. So that's in detail that we choose a real problem and collected the related data. It's a modeling procedure that I just want to summarize something that I just say, and we choose a real question and collected the related data, and also choose a method converted data to vector or to the tensors, and also decompose the real problem to the several machine learning and the math problem, and solve the machine learning problem individually and combine them together. And finally, the most important thing is to check is your solution directly solve your problem. Okay, I say a lot of words. I think a lot of people didn't catch all of this. So we see one example. It's a consultant project. No, it's not a consultant project. It's a project that we help a news platform to build their recommendation system. So we can see how we figure out a recommendation system from through the modeling procedure. It's a user-centered recommendation system that you can see every individual user to this platform, they will see the different recommendation result. The recommendation result may be with the title that some article you might interest in, something like this. So it's the architecture, the naive architecture. You need to get a news data feed, and you need to get the user behavior, and you need to build a responding server with high availability. So, and the most important thing, you need a back-end machine learning engine behind all servers. So it's a naive architecture to a recommendation system. And it can also apply in different kind of area. It can also apply in the e-commerce and also a lot of things. Yeah. And the first part of modeling procedure is about the problem and the data. So we can see for a news recommendation system, the most important business problem is how to make users reach more news they want to read. So how to achieve this kind of business problem? You need two kind of data. The first kind of data is news data. that you have the news title and news body and the news time and the category. And the other is user behavior data. The user behavior data is much more important to a news data that can help you to decide which news you want to recommend to each individual user. So we recall 3 types of user behavior data. The first type is user view the news, the view action. The second type is click action, that user click the recommendation result. And the third is the most important thing, and a lot of people always forget these kind of things. The user didn't click the link. When you are push 10 results to your user, that he may click one or not click one, not click one of them. So if he click one and the remainder 9 he didn't click, it's really, really important. And most of engineers will forget it. They recall only the things the user click. So I highlight it. So the second part of modeling procedure is how to make your data to your vectors. Here we have 2 kinds of data. The first kind of data is text data. So you can do a lot of text mining or NLP. So you can make your data into vector by 10 document matrix. Or you can use word to vector. Here are 2 links, then you can see the examples, all written in Python. And the user behavior data, you can also use some useful tools like Spark Streaming or Kafka, or the tutorial that yesterday just tell us that there is a TryDB that you can use to do the event sampling. And after you do the event sampling, you can convert sort of your user behavior log into maybe user view or user click or user non-click, user item matrix. Just like this. This is user item matrix. It's user in your left side and the item on top of the matrix. So you can control user item matrix and the item matrix that view after view or view click after view. So you can also construct the cube with user item and time, or user item and time, the 4-dimensional cube. Then it will help you to do the following modeling things. Yeah, after the second part, the third part is how to convert your real problem to the machine learning problem and how to solve the machine learning problem individually. So the real problem is how to make users reach more news they want to read. So we decompose the business problem into the 3 machine learning problems. The first is the hottest and then the newest recommendation. With recommendation, users to read the hottest and the newest news. So the second part is content-based relation, and the third part is collaborative filtering. So the first part, the mathematics behind the first part is sorting. So it's really easy to find out what is the newest news and what is the hottest news. And the second part is content-based relation is clustering. After you transfer your data into the vector by 10 document matrix or the skills in word to vector, you can do a lot of clustering things, and you can also do the topic modeling. It's the same thing of clustering and the topic modeling. You do the same thing. But different vectorization, you do the same thing on different vector style. So, sorry, it's Chinese corpus, so it's on Chinese. It's just do the clustering. It's different cluster and the topic, and you can choose one article and find the most similar articles. Yeah, and the third problem is collaborative filtering. You can do this by matrix factorization or matrix computation skill by solving this objective function. It's the regularization term of this objective function is in nuclear norm. It's the one norm in your eigenvalue space. So it's not the original one norm. Yeah, it's nuclear norm. So you can apply the method to an image that with only 20% information and reconstruct it. So you can also use this kind of scale in your data cube or data matrix. Then you can get the recommendation result. Complete your user item matrix, then you can get the recommendation result. Yeah, the fourth part of modeling procedure is combine the solution together and check it to a real problem. So there are two kinds of methods you can use here. The first type of method is ensemble learning. You just combine the weak ranker together to a strong ranker. And the second kind of method is reinforcement learning. You can use more user feedback after you combine out the ensemble learning model, then you can improve. So the first method, ensemble learning, is help you to deal with the static combination. And the second, reinforcement learning, is helps you to deal with the problem that you want to dynamically to improvement your model. So that's two kind of method. And here we can see that every news has its time scores. It's the sorting of time. So the last score means the newest the news is. So the similarity score means that two articles, how similar two articles. So zero is itself. So there are two ranker here, two weak ranker we construct. So we can easily to put the weighted sum of two rankers to construct a new ranker. Just the first ranker multiply 0.7 and the second ranker multiply 0.3. Then you can construct a new ranker. And after you construct a new ranker, then you can get a new ranker. And you can also apply the weak ranker here and the strong ranker. So you can construct a deep neural network on top of your weak ranker. Then you can get a lot of strong ranker. So that's what the things I do in Taiwan. So let me just recap that the modeling procedure has 7 parts. The first part is about the problem. The second part is about data. And the third part is data to vector. And the fourth part is real to machine learning. And the fifth part is solve machine learning problem. And the sixth part is combine the solution. Final part is check the solution. Okay, let's go to the most important part of this poll. It's the blindness of the modeling procedure. So what is the blindness of each part? We are discussion. So I will give you a lot of. The first part, the blindness of first part is from the problem and data. So there are two things, but they are highly related. So the problem you ask must relate to the data you use to solve it. So what kind of data you need to collect to solve the problem? It's a problem-driven thinking. You think from problem, and from the problem, what kind of data you need to collect it. And most of the time, our client has a lot of data, a lot of data. they think from another side. They have a lot of data. They can think with this data what kind of problem they want to solve. But most of the time, they tell you that they want to solve problem A, but actually they want to solve problem B. It's the problem behind problem. Yeah, so just like this. So how to find, is there some blindness in your data and problem relationship? So you can check these two questions. Is there some relation information in your data, or could the problem answered by this data? You can check these two of questions in your modeling procedures. This is the largest bookstore in Taiwan. We help them to solve this kind of problem. So one day, their manager asked me that could you use our post data to find some method that can help our bookstore convert those users who originally dislike us. So would you think the post data has this information? If yes, raise your hand. So if no, raise your hand. So why do you think there is no? Yeah. And 2 days later, the manager asked me another question. Could you use our post data to find potential users? So I asked him, could you define the potential? He said, the potential means users want to buy it, but they haven't. Maybe post data have some information. You can do the retargeting things, but most of users, they read the book, but they didn't buy. And there is no record in your post data that tell you which user read which books in your bookstore. So I think there's still no information in your data. Yeah, you can just do the retargeting. Yeah, here is the post data. It generates the place generating data is the important thing that you need to go there to feel in what kind of situation that data comes from. It's very important. Yeah, I think the data from post can tell you only the information about the converted user. There is no information about dislike and unconverted. But if you create an app that help user can scan your book and match the common interesting users, and then you can get a lot of data from users, and then you can get the data. Yeah. So we can think in a two way. The first is data-driven, that you have post data and what kind of problem that you can solve. And the second is the problem-driven, that you can see that the most important problem about the bookstore is how to gain their revenue, and what kind of data that can help them to gain their revenue. It's a problem-driven. The second case study is location-based book search. It's a story about delicious is not delicious. Because the delicious is a word, and the delicious is perceptions. 3 years ago, my friend constructed a location-based book search service. He crawled a lot of reviews and comments for the restaurant from the website. One day he asked me, "Hey George, why the food my system recommend me, that I think all of this is awful. So why my system wrong?" So Is that I train a model with the wrong algorithm, or is that I use the wrong parameters? And how can I adjust it? So I just answer him that it's not a mistake of your algorithm and the parameters. It's about the information you want. It's not in your data. So delicious is a kind of perception, and it's about the feeling after you're eating. So, but the delicious is a word, so which you got the perception, then you write it down. So they are in the different classes. Yeah, the words is inherit from the string, and the delicious is inherit from the perception. So they are different classes. So you can think that the perception is the first-hand data, and the string is the second-handed. Yeah. So what are you feel and how you cut it down. And the third blindness from the data is about the bias of the data. So if machine cannot learn by itself, it's just like a child. It learns by training data. Sometimes it will train badly. So if you train your model with only black color background images, then it can distinguish the image with white color background. So it's also an important thing. So the second part of blindness of modeling procedure comes from the data to vector. So the blindness comes from the data to vector. You need to ask your model this question: is there any information losing when you are converting your data? This is a unigram example that there are two kind of string. I love it and it loves me. It's no problem in English, but it generates some problem in Chinese because I and me are the same words in the Chinese. So they are generate the same vector here. So they generate the no difference vector. So you cannot distinguish these two sentences in this kind of vector space. So it generates some trouble if you want to distinguish them. So it generates some blindness. And another blindness comes from the mathematical concept. It's the gap between the math and the real words. And when putting the unit back, so you can find it. It's an elementary school math. 103 minus 100 is equal to 6 minus 3. Is that true? If you think true, raise your hand. Yeah. But when you put back the units, so you will see the different word. Yeah. $103 minus $100 equal to the $6 minus $3, but $103 stock minus $100 stock. You think the difference of $103 stock is 3%, but the right hand side is 100%. So it's different. So you cannot use this kind of coordinate to analyze your data. So you need to change another coordinate. So which coordinate is most proper coordinate for analysis stock data? It's a real difficult problem. If you are interested in this part, you can discuss with me after my talk. And the third blindness comes from the transformation of your machine learning problem. It comes from the frameworks, the blindness of the machine learning frameworks, the blindness of the classification, and the blindness of clustering. Imagine you train an orange apple classifier, and the classifier just made a banana. Then the classifier will recognize banana is orange or apple. So how to solve this kind of problem? This kind of problem is also generated in the digital classifier middle alphabet. So it's a model I construct with the deep neural network. It gets 98% accuracy in the meanness data. But when it met an alphabet, then it doesn't work. So how to solve this kind of problem? And for clustering, we always want to force 2 points in the same cluster, but we cannot do this in clustering. So how can I do this? The key fact is we always meet some data with labels and some data without. So we cannot use only supervised learning or only unsupervised learning to perfect solve our business problem. We cannot use this. So how the label propagation and how to detect the new labels is the most important 2 questions to solve if we want to solve the real business problem. So the new data and new labels are coming all the way in the e-commerce retailers and the news platforms, because there are a lot of new products in e-commerce and retailer every day, a lot of in Amazon. And a lot of news generate every day in your news platform. So it comes from a lot of new category, a lot of new category news, category products. So it is really, really important to solve this kind of problem. So how to solve? We can use 2 kind of approach. The first approach is use classifier, just like clustering method. It's called incremental classifier. You can use 1 versus O classifier to build an incremental classifier. And the second is use a clustering method just like a classifier. It's a machine learning. So in an incremental classifier, you construct 2 classifiers, 1 versus O. The first is apple or not apple. The second is orange and not orange. So if the banana in the both rejections area, then it generates a new cluster. So you can use your classifier, just do things like you do clustering. So another thing is metric learning. How to use this is the most. I like this kind of algorithm, and I use most in our production. And what is metric learning? You learn passing definite metrics that help you to compute the distance in another way. So in a Euclidean distance, the red and the blue point are near to the center green point. Use the Euclidean distance to compute. But if you change another distance computing method, then it changes. It push out the blue point and push out the red point, and it pull the same color point. So we learn that if we have a partially definite matrix, we can decompose it into 2 matrices and make the transformation. So you can do this. And another example is sandwich data set. In sandwich data set, after the transformation, your data will become here. You can use k-mean clustering to do the classifier doing. Yeah. Okay, it's almost end. So actually, you can use deep neural network to construct metric learning stuff. Actually, you can use, and the metric learning will give you another viewpoint to see the world. It's always give me. So remember that whatever you observe and whatever you see, you draw. And thank you for your attention. Yeah. That's why I put this Reno picture, because I want to remind me that everyone has its own blindness. So do I. So unless I can understand more about my blindness, I cannot overcome the challenge. So that's why I share this to everyone that enjoy it. Thank you.
Thank you. And again, we got some more talk.